Hello dear students, today I will be discussing about the double slit diffraction pattern. And obviously it is due to the Fraunhofer effect, that is the source and the screen both are at infinite distances, as you know, for the Fraunhofer diffraction. So that is the parallel rays. So you know that how this arrangement is made, that is to shift the source and the screen to infinity, as if the source and the screen are at infinity. So what you need to do, so that is what I have already shown to you during the last class of single slit, and that will be not repeated. So কি করে তুমি এগুলোকে ইনফিনিটিতে পাঠাতে পারো সোর্স এবং স্ক্রিন, সেটা আমরা আগের ক্লাসে বলে দিয়েছি, that is by using two convex lens on either side of the diffracting element. In this case the diffracting element is a double slit. Now what is a double slit? You see that I have already drawn over here because this saves some time in the class, so at least it will save 10 to 15 minutes of the class, which I can invest on some physics discussion. And secondly, I can also draw at my own pace, and I may try to draw a better diagram, so instead of drawing live on the class. So সেটা আমি এখানে করেছি, so এটা দেখতে পাচ্ছ. So this is the pattern, this is the diffraction that I have shown to you. So one is just at the 0-degree angle, so that is the central diffraction element, that is the central of the diffraction pattern. So I don't know that whether it will be bright or dark, so it cannot be predicted beforehand. And you see that this is the diffraction at some other angle theta. And here you can see that last class there was only a single slit, আগের ক্লাসে শুধু একটাই এখানে slit ছিল, there was only a single slit, but here you see that I have a slit in the bottom also. There are two slits, and the two slits are separated by a distance b, and this space is opaque. এখান দিয়ে light pass করবে না, so light will not pass through this is the opaque space. So how this can be done? So double slits are easily available in your colleges. Once again, তোমাদের কলেজে double slit আছে, you have an experiment on double slit, so you can perform it and you can get the fringe system, the diffraction system. So definitely once again you see that within the geometric shadow region you will be having some you may have the pattern. You see that this is actually a shadow, এই যে এখানে যে শ্যাডোটা এটা যেটা দেখতে পাচ্ছ, so light will just be block over here, but still you find some effect in this particular region, and that is due to the mutual interference of the secondary disturbances that are originated from the two wave fronts in this region and this particular region. So that is the two effects that you will find. So first of all, you know that the Huygens principle, every point on the wave front is the source of secondary disturbance, and the second point is that the secondary disturbance mutually interfere among themselves coming from a particular wave front. একটা particular wave front থেকে যে secondary disturbance গুলো emerge করছে, those secondary disturbances interfere among themselves. So that is the issue that is going on over here, and I hope that you are getting it and definitely enjoying the things. So I have shown two patterns over here, one at 0-degree angle and another is the diffracting angle at theta. So I have written also something. Let us consider a plane wave front of wavelength lambda incident normally on a double slit, each of width a, separated by opaque distance p. So এটা হচ্ছে width টা, so this is the width, that is a, and these are separated by some opaque distance which is b. Now a plus b is called the double slit constant. A plus b টাকে double slit constant এখানে বলা হয়. So next I continue. We have to find the intensity distribution. We have to find the intensity. We have to find the intensity. We have to find the intensity. We have to find the intensity distribution. We have to find the intensity distribution. We have to find the intensity distribution pattern. We have to find the intensity distribution pattern due to the diffraction. Due to the diffraction, we have to find the intensity distribution pattern due to the diffraction due to the two slits. Due to the two slits. Okay, we have to find the intensity distribution pattern due to the diffraction, due to the diffraction from the two slits. Due to the diffraction from the two slits. Okay, from the two slits. So that is what you need to find over here. So এটা আমরা এখানে বের করতে চাইছি. Now for this particular purpose we will just draw a magnified form of this particular diagram. আমরা এটারই একটা magnified form আমরা নিয়েছি. We will consider a disturbance to be incident over here. So now I will go to the formal mathematical theory of this. So এবার আমরা এই ম্যাথমেটিক্যাল থিওরিটা দিয়ে স্টার্ট করব. So for the mathematical theory, you know, first of all I will write, let us consider a disturbance. Let us consider a disturbance to be incidence. Let us consider a disturbance to be incident. Let us consider a disturbance to be incident on the slit. On the slit. Let us consider a disturbance to be incident on the slit represented by. So we know that the complex disturbance we actually use to represent by y is equals to some c e to the power I omega t. This is the initial disturbance that I am speaking of. And now as the disturbance propagates, there will be some phase difference from the initial point. So we need to calculate those phase differences, that is omega t minus kx, as it is a progressive wave, and then we will go for some mathematical treatment. Things will be very simple, you believe me. So প্রত্যেকটা জিনিস খুব সহজেই আমি দেখাবো. You just follow the step, you will enjoy it. The magnified diagram is also drawn over here, so that will also save some time. So if this is the entire disturbance, so what is the disturbance per unit length incident over here? So the disturbance incident per unit width of the slit. So the disturbance, so the incident disturbance, so the incident disturbance per unit width, so the incident disturbance per unit width of the, so the incident disturbance per unit width of the slit will be, so per unit width it will be, so I just write it next, so that would be some equals to, that will, I will be writing it to be C by A e to the power I omega t. Got it? C by A per unit width, the width was A, so it is C by A e to the power I omega t. So that is the disturbance per unit width incident over here. Okay, so hopefully you have got it once again. So নিশ্চয়ই বুঝতে পেরেছো কি বলতে চাইছি। So actually I consider a plane wavefront over here. So আমরা এখানে একটা plane wavefront নিচ্ছি and এখানে আরেকটা plane wavefront. So there are two openings, so there will be the consideration of two wavefronts over here, right? Okay. Now here are some, this is the magnified form of the diagram. So you see, so let me just zoom out this one such that the entire diagram is visible to us. Let me zoom out this. আর একটু zoom out করে নিই। Yeah, so I hope that it is now visible to you. So I will just show it to you and then again zoom in. So এখান থেকে দেখো, so just the same diagram that I have been doing in my last sessions. So that is z equals to 0 is this particular point. So this one I call z equals to a. So এটা যদি 0, এটা যদি a হয়, so this is after a distance of b. So that would be a plus b, right? A plus b is d. And if this one is d, তাহলে এটা আবার হয়ে যাবে d plus a, because this width is again a. So the slit widths are a and the distance between the two slits is b. The same thing I have considered over here, but last time you see in the case of a single slit, I have taken the origin where I have taken the origin at the center. I have taken the origin at the center in my last class. I could have taken it at the end also. So then just the integration limit would have been from 0 to a. আমি সেন্টারেও না নিয়ে এন্ডেও নিতে পারতাম লাস্ট ক্লাসে, তাহলে ইন্টিগ্রেশনটা 0 থেকে a পর্যন্ত হতো। You could try it, okay? So you can try it, but under that circumstances you will see that your calculations will have some difficulty and you need to tackle with it. ওই যে এক্সপোনেনশিয়ালে যে দুটো টার্ম ছিল, there are, as I have integrated from minus a by 2 to plus a by 2, so I have some e to the power I theta and I have some e to the power minus I theta, which I can replace by some sin theta using the Euler's formula. But if you take 0 to a, then one of the term will have exponential e to the power I theta and another term will be e to the power 0 due to the lower limit. I hope that you are getting it, and that will give you 1. So then you need to tackle the calculations properly by taking some e to the power common and all those. তখন ওখান থেকে e to the power I theta by 2 you have to take it common and then adjust and perform. So in order to avoid all those, I have taken it from the center, and as you know from your first semester course that under that cases the integral is to be done from minus L by 2 to plus L by 2, right? But here I just take it from where? So here I take it from one end to avoid any type of difficulty, because the system is a bit difficult in comparison to the last one. So the incident disturbance per unit width of the slit I have calculated up to this portion. Now this is going to P, and I consider a small element z at a distance dz from one end of the slit. Okay, so here I write it, তাহলে সেটা আমরা লিখছি এখানটাতে, আমরা যেটা কনসিডার করেছি সেটা লিখতে হবে। We consider a small element dz, we consider a small element dz at a distance, we consider a small element dz at a distance z from the lower end, at a distance z from the lower, at a distance z from the lower end of the, from the lower end, at a distance z from the lower end. Okay, let us consider a small element, at a distance z from the lower end, nothing else, from the lower end, small element dz, okay, at a distance z from the lower end. I hope that you are getting it, but এখানে কিন্তু একদম এই 0 থেকে d by plus a you cannot integrate that, because in between this space is to be rejected. It is opaque, light cannot pass through it, so you have to reject this space. So my integration will be from 0 to a, and then it will be from d to d plus a, right? So this space is to be rejected because light cannot enter through this opaque space. So we consider a small element dz of what? I should write dz of what? dz of the wave front. So people actually don't write this, but I should write it. So okay, so this will help you to understand. আমরা ওয়েভ ফ্রন্টের একটা ছোট পোরশন কনসিডার করছি। Let us consider a small element dz of the wave front at a distance z from the lower end, at a distance z from the lower end. The possible values of z are given over here, right? So now what is the resultant disturbance at P? So what will be the resultant disturbance? You try to maintain parity from the last class. So last class যেইভাবে লিখেছিলাম তার সাথে একটা parity maintain করবে। আমার যদি একটু একটু চেঞ্জ হয়ে যায়, if it gets changed, so then you try to maintain at the same level. একই রকম ভাবে লেখাটা রাখার চেষ্টা করবে তোমরা, you will try it. So the resultant disturbance at capital P, the resultant disturbance at capital P due to this element dz. So what will be the resultant disturbance at capital P due to this element, small element dz? So that should be some d of yp, small element, so small, so per unit with it is c by a e to the power I omega t. I must consider the phase difference as it is a progressive wave, so it is kr because this point is at a distance r, and I should multiply by dz because it was per unit with, and I have taken a dz with, just unitary method. এককের জন্য এটা হলে dz কত হবে, for unit length it is that, so for dz it will be how much. So again the things are going on properly, and hopefully everybody of you are understanding and definitely enjoying the calculations. আচ্ছা, এখানটাতে এই রিলেশনটা এখান থেকে ঠিক আগের বারের মতন আবার sin theta টাইপ একটা ক্যালকুলেশন আমরা করে নেব। We will do a calculation of that type of sin theta over here. So after this I come to this point, ওই জায়গাটা ছেড়ে দাও, হ্যাঁ, you just leave that space. So d of yp is equals to some c by a, then it will be some e to the power I omega t minus kr0, and then it will be some I k sin theta into dz. How do I get it? I will be discussing with you. আমি তোমাদের সাথে ডিসকাস করব কি করে পেলাম আমি। So you just write over here sin of theta. What is the value of sin of theta? So sin of theta from this triangle, also you name the triangle, from triangle QMN, you may write this, if this angle is theta, then by geometry this must also be theta, so এটাও থিটাই হতে হবে by geometry. So what you understand from here is that, কেন বুঝতে পারো তো, এটা যদি থিটা হয় এই গোটা অ্যাঙ্গেলটা 90 ডিগ্রি আছে, this entire angle is 90 degree, so obviously this angle is how much, this angle is pi by 2 minus of theta, and this angle is how much, this angle is pi by 2, so this must be theta such that the entire sum is pi, তাই না? এইটা দেখো pi by 2 minus theta আছে because this is theta and this one is already pi by 2, so the sum of the three must be pi, so pi by 2 minus theta plus pi by 2, so এটাকে theta হতেই হবে, so this will be theta, so theta gets cancelled and you have pi by 2 plus pi by 2, that is pi, right? So that's the idea, nothing more than that. So আর সোজা জিনিস একদম। so এখান থেকে যদি sin theta বের করি, এই জায়গাটা পারপেন্ডিকুলার আছে, so sin is perpendicular by hypotenuse, লম্ব by ভূমি, so that means that it is mn by mq, it is mn by mq, so mn by mq, so my mn comes out to be, তাহলে এখান থেকে আমার mn টা চলে আসে হচ্ছে, what is my mq over here, rather mq টা কত হবে এখানে, what will be the value of this mq? Oh, here I should what is my mq then? That distance is z, এই পুরো ডিসটেন্সটা z আছে, so mn is mq is z over here, so that is simply z sin theta. So my mn comes out to be this z sin theta. Let us highlight this properly for understanding. So এটাকে হাইলাইট করে দিলাম, হয়ে গেল এটার কাজ, this is done. আচ্ছা, তারপরে আর কি হবে, what else আর কি হবে, mn equals to z sin theta, else what else? So now, and from the diagram you also come to know that this r is equals to definitely r0 minus mn. It is also true, look at the diagram, this r, so what is the difference, path difference between these two? So these two are equal, so this one, and after drawing the perpendicular, so that is the idea of drawing the perpendicular. Suppose these two lines are parallel, so what is the path difference between them? তাহলে এদের মধ্যে ডিফারেন্স কি আছে, you drop up a perpendicular over here, so this amount is the difference between them, so that is what is being done over here. So একই জিনিস ওখানে করা হয়েছে, so this is r and this is r0, you drop a perpendicular, so this extra portion over here is the excess, so এটা হচ্ছে excess pathটা, so that is why I write it to be some mn, so ঠিক আছে r0 minus mn, so I can write it to be r is equals to r0 minus of mn মানে z sin theta. And here I used to write another point over here, আমি আরেকটা পয়েন্ট এখানটাতে লিখতাম, সেটা হচ্ছে I used to write another point that was r equals to r0 What is R0? So people actually ask that what is R0? R0 is the value of R. R0 is the value of R. R0 is the value of R at Z equals to 0. If you put Z equals to 0, then you will get R0. ঠিক আছে? R0 is the value of R at Z equals to 0. Z এর জায়গায় 0 put করলে you get R equals to R0. That means that as you are moving away, this distance is diminishing. এটা বলতে চাইছে যে তুমি এখান থেকে যত উপরে যাচ্ছ, as you are moving in the upward direction, this distance মানে from the slit to the point P is gradually decreasing. Okay, from the slit to the point P, this lateral distance is gradually decreasing. So that is what we mean over here. So এটাই বলতে চাইছে, আর কিছু না। ঠিক আছে, চলো হয়ে গেল এটা। So this arrangement is being done. So that is how you understand that this R is replaced. তাহলে basically এখানে R টা replace হয়েছে. This R is replaced with what? This R is replaced with R0 minus Z sin theta. R is replaced by R0 minus, so minus minus becomes plus. This minus and this minus becomes plus. So that is why it is, this is what? Z sin theta. So what did I miss? তাহলে কি মিস করেছি? একটা Z এখানে তো আমার মিস হয়ে গেছে. I missed a Z. Last day I have missed something else. এর আগের দিন আবার অন্য কিছু মিস হয়েছিল. আজকে Z মিস হয়েছে। So লাগিয়ে দিচ্ছি Z, I put it I K Z sin theta. Okay, easy things. So that is what I get, and then I will be writing it to be, তারপরের লাইন হচ্ছে d of yp, I write it to be some capital R e to the power I beta z dz, just like the single slit class. Single slit এ যা ছিল তেমনই কিছু একটা লিখতে চাইছি আমি. So it's better that I just continue this line. এই লাইনটাকে আমি কন্টিনিউ করে দিই, that would be better. So where R I have taken to be, what is the value of R? So where capital R I have taken to be this C by A exponential of e to the power I omega t minus k r0, and this এটা R হয়ে গেল না, and this beta is what? Beta is equals to k sin theta. You know that beta is a very important parameter. So beta টা লাগবে আমাদের আবার পরে, later on when you calculate the positions of maxima minima, we will need this beta. So let us just integrate this to find the net effect at the point capital P. That means that this is now interfering. So once I integrate, that means it is interfering. তাই না? Interference মানে কি? y1 plus y2 plus y3. So here also I am taking the integration. So as I am taking the integration, that means I am taking the interference from the waves that are coming from the wave front. একটা পার্টিকুলার ওয়েভ ফ্রন্ট থেকে যে ওয়েভস গুলো বের হচ্ছে, আমরা তাদের ইন্টারফারেন্স নিচ্ছি. I am taking the interference of them, and that is why I integrate this, right? People integrate, but many people don't understand that why they are integrating. So they are integrating because Fresnel has asked us to integrate. Fresnel আমাদেরকে বলে গেছে 300 বছর আগে, 300 years ago, Fresnel has said that you have to integrate. So that is why we are trying to doing, that is what we are trying to do over here. So the net disturbance, thus the net disturbance, oh, I should zoom this one. So I forgot to just zoom in this. I am sorry. So may not be these were visible to you properly. So I remember now. Thus the net disturbance, that the net disturbance at P, thus the net disturbance at capital P, considering the effects from both the slits, considering the effect from both the slits, what happens? Considering the effect from both the slits will be, so what will be that? So that will be some yp. So if I call it yp, so then yp will be this integration of dyp, and once I integrate this, that will be some capital R e to the power I beta z dz divided by it should be what is the lower limit? Just have a look over here. So what should be the lower limit? The lower limit is 0. This is somehow I have to, I cannot write it in this particular way. এটা এইভাবে লেখা যাবে না, because the integration is over here in two parts. So the first part of the integration is basically from it is from 0 to a. প্রথম ইন্টিগ্রেশনটা 0 থেকে a পর্যন্ত r e to the power I beta z dz, and the second part of the integration is, you see that there is an opaque space, so it is d to d plus a r e to the power I beta z. I hope that you are getting it. নিশ্চয়ই বুঝতে পারলে কি বলতে চাইছি. Is it clear to you? Just have a look over here. So I have taken from 0 to a, and then I have taken from d to d plus a. Okay, I have taken from 0 to a, and then I have taken from d to d plus a. That is what I am trying to do over here, right? I have left out the space where the light was unable to pass. due to the slit separation. So the net effect YP will be, so এটাকে calculate করো, you just try to calculate this out. So first part, যাই হোক না কেন r by I beta will be common, entire common, r by I beta পুরো common নিয়ে নাও, it will be common from all the terms, and the first one will give me e to the power I beta a, প্রথমটা দিচ্ছে e to the power I beta a minus of 1, e to the power 0 is 1, plus this will be e to the power I beta d plus a minus e to the power I beta d, right? You get something এরকম কিছু একটা পেলাম। এরপরে হচ্ছে now it will be r by I beta once again, আবার r by I beta e to the power I beta a minus 1 plus e to the power I beta d, you may take common, so it will be again I beta a minus 1. Okay, so then it should be capital R by I beta e to the power I beta a minus 1, you take common, so another term will be e to the power I beta d plus 1. So that's it. So that is what you have at the present moment. So এইটুকু জায়গা তোমার কাছে আছে, you put the value of r over here, so yp comes out to be some and you may simplify it further. So এখানে r এর ভ্যালুটা বসাচ্ছি, হ্যাঁ, c by a e to the power I omega t minus kr0 divided by I beta, and then it is e to the power, same things, e to the power I beta a minus 1, e to the power I beta d plus 1, right? And okay, it's fine. So you find yp star from here, এখান থেকে yp star টা বের করে নাও। So yp star will give you c by a e to the power negative I don't write the argument, it is I beta, and this one will be e to the power minus I beta a minus 1 e to the power negative I beta d plus 1. So these are the complex conjugations over here, and what will be the net intensity? Therefore intensity at capital P, what is the intensity at capital P? So intensity at capital P will be IP equals to yp star, তাই তো, it is yp star. So that gives me, for real part it is only yp square, or yp square ও করতে হবে, you will just take the amplitude square, but since there is complex magnitude, so you have to take the conjugation. So yp star actually gives you c square by a square, this, oh, you see that there is a negative sign, এখানে minus sign আছে I beta, এখানেও তো minus হবে, c square by a square, I square is minus 1, minus gets cancelled, beta square, so c square a square by beta square, what do I have over here? c square a square beta square, ঠিক আছে, এটা একটা টার্ম আসলো, this exponential part gets cancelled, e to the power I e to the power minus I gets cancelled, and then these are the conjugate pairs. So এখানে আমি পেয়ার করে করে লিখবো, দেখো আমরা পেয়ার করে লিখবো e to the power I beta a minus 1, তার সাথে হচ্ছে e to the power minus I beta a minus 1 হলো, তারপরে হচ্ছে এই দুটো টার্ম, the next two terms I just use a different color to make us understand, e to the power I beta d minus 1 and e to the power minus I beta d plus, why it is plus 1, or plus ই ছিল এটা, so this was plus, so this is plus 1. Simplification will take some time, and that is what you should understand properly, but while performing the mathematics you should not forget the physics টা ভুলে যেও না, because at the end of the day you are a physicist and you should understand that why you are performing the mathematics. So the mathematics is being done because of the statements of Huygens and Fresnel, so that is the reason that we are trying to go through this mathematics. So next, proceed again, so আবার proceed করা যাক, so this gives me IP once again. So এটাকে ভালো করে সিম্পলিফাই করতে হবে, because this will give you the intensity distribution function, and that will decide that where it is bright, where it is dark, or whatever be the issues, the entry of light within the geometric shadow, so everything will be given by this particular calculation. So within the next 5 minutes I hope that you will get the distribution function. So if I just start multiplying these two, so এবার আমি যদি এই দুটোকে মাল্টিপ্লাই করি, so if I just start multiplying these two, so that will give me, so you see that it will give you 2, because e to the power gives you 1, and this minus 1 into minus 1 gives another 1, so that's why it's a 2. বুঝেছো তো, 2 কোথা থেকে, exponential multiply করো, you get a 1 cancellation, and minus 1 multiplication gives you another 1, so 1 plus 1 is 2, and then the remaining term you can put it on a bracket. So this will actually help me to use the Euler's formula, e to the power I beta a minus of e to the power minus I beta a. that sine cosine formula can be used over here. Cosine will not come, you will have sine only. So I put this in a third bracket. So এইটাকে আমি একটা third bracket I put it on a square bracket and then I use another square bracket. So this one, so e to the power, again this gives me 1, 1 plus 1 is 2. So this is a 2, and then you have within the parenthesis you have e to the power I beta d and plus e to the power minus I beta d. Right? So হয়ে গেল। আচ্ছা, এখান থেকে গল্প শুরু করি। Again I start the story, a square beta square. So this gives me, if I take the 2 common over here, so এখান থেকে দেখো আমি যদি 2 common নিয়ে নিই না, if I take a 2 common from here, so then this will actually become, তাহলে এটা কিন্তু হয়ে যাবে, this will actually become 1 I make a mistake, I hope একটা ছোট মিস্টেক হয়েছে মনে হয়, e to the power minus 1, yeah I make a mistake over here, slight mistake, hopefully you people have recognized. There will be a minus common, this will be plus, এখানে minus common থাকবে, ভিতরটা plus থাকবে, it will be plus, and as it is plus, once I take a 2 common over here, এখানে 2 common নিলে এটা কি হয়ে যাবে, it will become 1, and if I take a 2 common, so there will be a 2 over here, so that gives you cos, so এটা তোমাকে cosine দিচ্ছে, ঠিক আছে। So virtually you take a 2 common, so this becomes 1 and this becomes 1 minus this exponential divided by 2, which actually becomes cos beta a. So I just skip a step over here, which helps us. তাহলে similarly পরেরটাও এসে যাবে very simply. So this will be so there will be a 2 common once again, so you take a 2 common and this becomes cosine of beta d. এটা চলে আসলো cosine of beta d, right? বুঝে নিলাম একদম fantastic way তে। So this gives me 4c square divided by a square beta square, and this is 1 minus cos beta a gives you 2 times of sine square beta a by 2. Cos 2 theta, you know cos 2 theta is 1 minus, cos 2 theta is 1 minus 2 sine square theta, right? 1 minus sine square 2 sine square theta. So it is just the formulae, those formulae, cos 2 theta formula use করেছি আমরা, হ্যাঁ, just using the formulae of cos 2 theta, 1 minus 2 sine square theta, আর এইটাতেও ইউজ করো cos 2 theta, which is 1 plus 2 cos square theta, 1 plus 2 cos square theta. এটা cos 2 theta, oh yeah I remember, cos 2 theta is 2 cos square theta, 2 cos square theta minus 1, so yeah ঠিক আছে। 2টা তো হবে না, 2টা কমন নিয়েছি, 2 I have taken common, that's why I was facing a difficulty. So 2 into 2 got 4, এই পার্টটা একটা চলে আসলো, and 1 plus cos beta is nothing but 2 cos square beta d by 2, ঠিক আছে। এগুলো তোমরা জানো, these are simple trigonometry, you know better than me. So এইখান থেকে, so from here you may write it to be further calculations, you take out 4c square, right? 4c square I just put aside, এটাকে বাইরে পাঠাও 4c square, এখান থেকে দেখো this sine square beta a by 2, this sine square beta a by 2 divided by beta a by 2 whole square, beta a I take together, এই যে beta a একসাথে নিয়ে নিলাম, and where from do I get the 2? This 2 into 2 gives you 4, এই 2 into 2 4 আছে, that 4 I take it in the denominator, আর এখান থেকে একটা cos square beta d by 2, fine, understood, একদম বোঝা হয়ে গেল পুরোপুরি, ঠিক আছে, একদম understood. Okay, next line. So next line will give me, don't forget what you are calculating, we are calculating IP, so this gives you I0. Last time you see this I0 was c square only, last date তুমি দেখবে যে I0 তে শুধু c square ছিল, কিন্তু এখন তুমি I0 তে দেখো 4c square, that means that the intensity has been 4 times, intensity কিন্তু 4 গুণ বেড়ে গেছে, in comparison to the single slit the intensity has increased 4 times, 4 times বেড়েছে কেন, why? Because it is a more exposure to light, এখানে লাইটের এক্সপোজারটা আরো বেশি, last time there was a single slit but this time there is a double slit, so the exposure is more, so that's why the intensity has grown up proportionately. So this one is sine square alpha by alpha square, this was the term for single slit, এটাই single slit ছিল, I0 sine square alpha by alpha square, but here you have another extra term which I call cos square gamma. So this is the double slit diffraction function, যেখানে আলফা মানে হচ্ছে আমাদের বিটা a by 2 আর গামা হচ্ছে আমাদের বিটা d divided. Okay, so here you have introduced an extra factor, that is gamma. So এখানে gamma বলে একটা extra factor আমাদের লাগছে to explain the double slit IDF. So this is the double slit intensity distribution function which I will be writing next. তো সেটা আমি এখানে লিখে দিচ্ছি. So I write it. This is the required IDF. This is the required IDF. This is the required IDF for double slit. This is the required IDF for double slit. Okay, double slit diffraction pattern. Double slit diffraction pattern. This is the required IDF for double slit intense diffraction pattern. So well understood, ঠিকঠাক ভাবে আমরা বুঝলাম, so we understand in a proper way. So now let me just give you some explanation of the terms. What is the explanation of this cos square gamma term? A cos square gamma কোথা থেকে আসছে? Where from are you getting the cos square gamma? So let me give you some explanation of those. It consists of, and you will definitely enjoy it, it consists of two terms. What are the significance of this term? It consists of two terms. So the first term is two terms whose interpretation are as follows. The interpretation of the terms are as follows. So the first one, that is the number one term. So number one, sine square alpha by alpha square. Sine square alpha by alpha square. So what is the origin of this term? So sine square alpha by alpha square is due to the diffraction, is due to the diffraction of light waves, is due to the diffraction of light waves from the individual slits, similar to single slit IDF, you have learned it on the last class. এটা আগের ক্লাসে পড়েছো তো, sin square alpha by alpha square তুমি যে আগের ক্লাসে পড়েছো, দেখো sin square alpha by alpha square you have studied on the last class, where you have said that the interpretation of this term is that this is generated from the single slit diffraction. এটা single slit diffraction থেকে এই টার্মটা জেনারেট করে। আর আরেকটা টার্ম যেটা আছে, there is another term which I call cos square gamma. So where from is this term generated? এই cos square gamma কোথা থেকে জেনারেট হচ্ছে? This cos square gamma is generated, this is very interesting, is due to the interference of the diffracted light waves from the individual slits, right? You see, so interesting, কি সুন্দর, দেখো এটা কি ইন্টারেস্টিং, how interesting it is. এবার তুমি আমাকে বলতেই পারো, if for a face to face discussion you may have immediately asked me, sir, who said you this is interference? আপনি কি করে বুঝছেন যে এটা ইন্টারফারেন্সটা? প্রথমটা বলে দিচ্ছেন ইচ্ছা মতন ডিফ্রাকশন, আচ্ছা প্রথমটা নয় মেনে নিলাম, the first, okay, তুমি বললে okay sir, I accept the first one, because I have studied in the last class that single slit is sin square alpha by alpha square. But who said you that this is the interference? Yes, I have a logic behind it. আমার কাছে তার লজিক আছে যে আমি কেন এটা ইন্টারফারেন্স বলছি। If you plot cos square gamma, what will happen? Cos square theta, যে কোনো cos square theta plot করলে কি রকম আসে আমাকে বলো। If you plot cos theta, what happens? If you plot cos theta, what happens? If you plot cos theta, so then the plot is something like this. এরকম হয় তো cos theta plot. This is the plot of cos theta. তুমি যদি এখান থেকে ড্র করতে, there was no objection, then I would have, কিন্তু তোমরা তো বলে স্যার আপনি sin theta ড্র করেছেন, cos theta ড্র করেননি, but that is sin theta cos theta is same, right? So it's just depend upon the position from where you are drawing it. So just এইটা ধরো ড্র করলাম না, তুমি বলে একটা আইডিয়াল cos theta আমি ড্র করছি, ধরো আইডিয়াল cos একদম, ওকে। So this is the cos diagram. So আমি কোসাইনের ডায়াগ্রাম আমি ড্র করছি, ঠিক আছে। ড্র করলেই হলো একটা, more or less you just sine and cosine are the same version, just the opposite phase. So you draw from here, you draw from here, wherever from here you draw, I don't care. So যেখান থেকে যা ইচ্ছা করো, এই নেচারটা আছে। This is cos. I am interested in cos square. Cos square করলে কি হবে? If I go for a cos square, then what will happen? If I draw cos square, then what will happen? Cos square draw করলে বলো তো কি হবে? So then this diagram will be not both sides, but this will be a single sided diagram like this. Cos square আছে তো, it is squared, right? So cos squared, right? Cos squared, বুঝেছো রে? Cos squared. And cos squared, this is the nature of what? এটা কার nature? This is the nature of what? All the bands you see are of same maxima. All the maximas are of equal height. And this is the nature. This is whose nature? This is the nature of interference. You just go back to the class of interference. Just go back to the intensity distribution function. Just go back to the intensity distribution function that you have studied in the class of interference. You will automatically understand yourself. তুমি নিজে নিজেই বুঝে যাবে যে তুমি কি করছো, what you are trying to do over here. Okay, you will yourself understand that what you are doing. In the class of intensity distribution pattern for the interference class, you will see that there was a term of cos squared delta by 2. তুমি দেখে নাও এর আগে তোমার যে ইন্টেন্সিটি ডিস্ট্রিবিউশনের যে ক্লাস ছিল সেখানে তুমি দেখে নেবে যে ওখানে একটা cos squared delta by 2, so there will be a term of that particular type cos squared delta by 2 if I take a1 is equals to a2. a1 আর a2 যদি আমি ইকুয়াল ধরে নিই তাহলে তুমি দেখবে cos squared delta by 2 টার্ম ওখানে আছে, and that cos squared delta by 2 is a manifestation of this one. Let me recall the intensity IDF. It will take some time, but still I must discuss with you for your proper understanding. এইটা ছিল তোমার intensity IDF for, this was the IDF for interference. ছিল তো এটা interference এর IDF. If you take a1 and a2 equal, so it will be a square plus a square plus 2a square into cos delta. So that will give you again 2a square you may take common, so it will be 1 plus cos delta. 1 plus cos delta, everybody knows that 1 plus cos delta is 2 cos square delta by 2, right? So this actually give you 4 times of a square into cos square delta by 2, and it is the plot of that only. Eta tai plot eta. So it is the plot of that cos square delta by 2 only, this one. Interference এর ক্লাসে করে দিয়েছিলাম, maybe I did not say cos square delta by 2. I have discussed with this general form, আমরা general ফর্মটা দিয়ে বুঝিয়েছিলাম maybe. So actually it is a cos square delta by 2 in the class of interference. So it is from the class of interference I come to know that cos square gamma is the interference. আর এখানে কাদের মধ্যে ডিফ্রাকশন হতে ইন্টারফারেন্স হবে? So from where do I have interference in this particular experiment? So in this particular experiment there will be some diffraction, and that diffraction is actually the result of the interference. So এই diffraction যেটা আমি পাচ্ছি এখানে, the diffracted light, so that diffracted light interfere among themselves. So এই diffracted lightটাই নিজেদের মধ্যে interference করবে, that will interfere among themselves, and that is why you get a resultant like this. Resultantটা হচ্ছে এরকম আসছে. This one is your term from the single slit interference, and then the single slit diffracted light, single slit যে diffracted light তারা নিজেদের মধ্যে interfere করবে, they interfere among themselves to give you a term like this, which is a together effect of this particular form. দুটো একসাথে নিলে এইভাবে আসবে. Probability of A is PA, probability of B is PB. So what is the probability that A and B will occur simultaneously? So PA into PB, right? So that is what I am trying to discuss over here. So সেটাই এখানেতে বলছি. ঠিক আছে, more or less. Don't think in that probability way, that's just an example to correlate the issues. So sin square alpha is the diffraction of light waves from the individual slits, similar to single slit, and cos square gamma is due to the interference of the diffracted light from the individual slits. So that is how you understand the things over here. So এইভাবে আমরা পুরো ব্যাপারটাকে একটা বোঝার চেষ্টা আমরা করছি। ঠিক আছে, তাহলে ফাইনাল প্যাটার্ন গুলো এবার আমাদেরকে ড্র করতে হবে। সো প্রথম আমরা লিখছি the diffraction term. So the diffraction term, no discussion is required for this, because the diffraction has already been discussed in my earlier classes. The diffraction term, that is sin square alpha by alpha square. So you will discuss it in a concise manner from the single slit class. Single slit ক্লাসের অনেক কিছু শিখেছিলে, সবকিছু বলা সম্ভব না এখানেতে। কনসাইজ ওয়েতে ছোট করে তুমি বলবে যে পুরো ঘটনাটা কি হচ্ছে, রাইট? ফলো দ্য সিঙ্গেল স্লিট প্যাটার্ন, ফলো দ্য সিঙ্গেল স্লিট, এটা নিজেদেরকে কিন্তু লিখতে হবে। দিস ইজ ইউ হ্যাভ টু রাইট ইয়োর সেলফ, ফলো দ্য সিঙ্গেল স্লিট। কি কি দেবে ওখানেতে, হোয়াট টু পুট, you will give some information about the principal maxima. Derivation is not required, just you give the idea of the principal maxima, কোথায় হয়, where it occurs actually. Next you give some idea about the diffraction minima. So where does the diffraction minima occurs? I will also recall the issue. Diffraction minima টা কোথায় হয় বলো তো, where does the diffraction minima occur? The condition for diffraction minima is A sin theta is equals to, I write some excuse me, I write some A sin theta is equals to n lambda. So the diffraction minima occurs at some a sin theta is equals to n lambda. So এই পয়েন্টে তোমার এটার গুলো হয়। So this occurs at this particular point where n can take all values except 0, where n belongs to integer, comma n not equals to 0. So all integers except 0 it can take for the diffraction minima, and the other maxima, and for other maximas, where does the other maxima occur? You know from the last class that it occurs as a multiple of pi by 2. So other maxima, first maxima, second maxima, you just look at the last day's diagram. এর আগের দিনের ডায়াগ্রামটা দেখে নেবে 1.43 পাই, তার মানে ওই ম্যাক্সিমাটা কোথায় হয়েছিল, একটা ম্যাক্সিমা 3 পাই বাই 2 তে হয়। the other maxima is 2.46 মানে হচ্ছে 5 by 2 pi, right? So this can be generalized as n plus half pi by 2, মনে হচ্ছে তাই তো, n plus half pi by 2. other maximas can be obtained at n plus half. other maximas are obtained at this theta equals to, theta is equals to, theta na alpha, কি হবে, alpha হবে, theta হবে না alpha. other maximas are obtained at alpha is equals to n plus half pi by 2. alpha and theta are related. Okay, if you put n equals to 1, the first maxima, you get 3 by কেমন লাগছে আবার দেখতে, 2n plus 1 pi by 2 করে দিই, তাহলে সব ঝামেলা মুক্তি। 2n plus 1 pi by 2, ঠিক আছে, 2n plus 1 pi by 2. as if it appears that the bright fringes are equally spaced, but they are definitely not equally spaced. এটা কিন্তু equally spaced নয়, because you know that the solutions, এগুলো exact solution নয়, these are exactly not multiples of pi by 2, so those are not exactly, they are separated by same distance, তা কিন্তু নয়, so they are not exactly separated like that. So this is how you obtain some 2n plus 1 pi by 2. So if you put n equals to 1, because n equals to 0 is for whom, n equals to 0 is for the principal maxima, and then if you put n equals to 1, so it will give you what, 3 pi by 2, n equals to 2, 5 pi by 2. So that is how you obtain all the possibilities over here. So এখান থেকে সবগুলো possibility এইভাবে এখান থেকে পাওয়া গেল। So where you understand this one. So এখানটাতেও তাই, n belongs to I, n belongs to I except n not equals to 0. Fine. That is everything we are able to understand for the single slit. And finally I also draw the pattern just for your just to recapitulate the issue once again. Just একটু recapitulate করার জন্য প্যাটার্নটা একটু ড্র করে দিচ্ছি। So gradually increasing the maximas. This one is the central maxima, suppose its width is also more, এটার width ও বেশি আছে, and also the intensity. So this side I am plotting the intensity, and this side I was plotting the alpha value, এখানে alpha টা প্লট করেছিলাম। Finally we will plot with theta. Finally তো theta respect প্লট করতে হবে, but okay, that's fine. So I draw something of this particular nature. So এরকম একটা কিছু আমরা ড্র করব। Got the idea? So that is the interference, that is the diffraction term. So এটাকে ছোট করে তুমি মোটামুটি করে লিখে দেবে। আমি লিখিনি, I didn't write the things, but you will write the principal maxima is this, that occurs at this, the minima can be obtained by this maxima. So this is what, very shortly you have to write, just within 2 minutes, because the main focus did not come till now. এখনো অবধি actual focus এর জায়গাটা আসেনি, right? So we will move towards the actual part of this double slit diffraction. So actual যে diffractionটা সেটা আমরা এখানটাতে আসছি, that is how it is different from the single slit pattern. So from the single slits you have lights, the diffracted light, and the diffracted light now interfere among themselves. So next I go for the interference term. So এবার আমি লিখছি the interference term. The interference term. Okay, the interference term. So interference term is my cos square gamma. So আমার interference term হচ্ছে আমাদের cos square gamma. So cos square gamma কোথায় কি রকম এফেক্ট করছে, so what is the effect of that cos square gamma? So now let us try to understand those issues. So cos square gamma কি এফেক্ট আছে সেটা আমরা এখানটাতে বুঝবো। এটা ডিটেইলসে করতে হবে, this has to be done details. প্রথমে ম্যাক্সিমা, তারপরে মিনিমা। So what are the terms of interference maxima? The maxima will be given by, so what is the condition for maxima? Don't write the maximas, the maxima. The maxima condition is, আচ্ছা এই বলো এটা কখন ম্যাক্সিমা হবে, when it is maxima. So it will be maxima when your cos square gamma is 1. It will be maxima when cos square gamma is equals to 1, right? So cos square gamma equals to 1, that means gamma equals to how much? So that means gamma equals to some m pi, where m belongs to integer. So gamma equals to some m pi. So cos square gamma equals to মানে gamma equals to m pi হবে কিন্তু gamma equals to m pi, right? Gamma equals to pi রে pi. m pi মানে কি? m pi মানে কি? What do you mean by m pi? 0 pi 0 0 pi 2 pi plus minus 0 plus minus pi plus minus 2 pi plus minus 3 pi এগুলোর কথা বলছি আমি। 0 plus minus pi plus minus 2 pi, these all. So cos square 0 is 1, cos square pi is 1, cos square 2 pi is 1 plus minus, right? So that is why gamma equals to m pi. So what is the gamma now? So gamma is actually beta d by 2. Just you find in your notes, you will find it. আমি লিখেছি উপরে, গামার ভ্যালু দেখে নেবে। বিটা মানে আবার হচ্ছে k sin theta. Beta is k sin theta and d by 2. That is m pi. And you remember the values of m. M এর ভ্যালু ভুলবে না কিন্তু, m এর ভ্যালু 0 থেকে স্টার্ট হয়। The value of m starts from 0. You please remember. Because some value starts from 0, some value start from 1. So that is what you should remember always. And this d is how much? D is a plus b. So এখানে লেখো k is 2 pi by lambda sin of theta. Theta is the diffracting angle. D is how much? D is a plus b. Diffraction, the double slit constant, m pi. So pi gets cancelled from both sides. 2 gets cancelled over here. And finally you have a plus b sin theta equals to n lambda. A plus b sin theta is equals to n lambda. These equations you always remember. This will help you to overcome different hurdles that you will find in your lifetime. So different hurdles, different examination that you have to cross in order to get something good. So these equations, so questions are generally set from here always. So a plus b sin theta equals to n lambda. This is the condition for the maxima in a double slit. Interference maxima, definitely interference maxima. The condition for interference maxima, you remember interference maxima kintu. And how does the interference and diffraction occur together? That is also is interesting and I will show it to you. এবং সেটাও তোমাদেরকে এখানে দেখানো হবে। So a plus b sin theta is equals to not n, it is m, because n is already used. n একবার ব্যবহৃত হয়ে গেছে। m lambda. I write it neatly. Sure. Now it is the interference minima. Interference maxima is done, the minima. So now the minima is given by the minima condition is. So what is the condition for interference minima? The minima condition is not so important. The minima condition is for interference, the most important is the maxima only. এটাই সবথেকে গুরুত্বপূর্ণ, এটা মনে রাখতে হবে। And here it will give, you will get just some 2p plus 1 lambda by 2. Pi by 2 এর multiple is the maxima, pi এর multiple is the minima. The minima condition is, so minima টা কখন আসবে? When this cos square gamma, that one will be 0. So when cos square gamma equals to 0, you get the minima condition. Cos square gamma is 0. So that means that gamma equals to what? So gamma equals to 2p plus 1 pi by 2. P starts from 0. P 0 থেকে start হতে পারে, where p belongs to some integer. When there is no restriction, I write integer, and if 0 is not possible, then I will write not 0. So if you just calculate this in the same manner, just putting the value of gamma, এই গামার ভ্যালু যদি এখানে পুট করো, just same way, the putting the value of gamma to be beta d, then putting the value of beta and d, it will come out to be, so এটা যদি m থাকে তাহলে এটা দেখে নাও কি হবে। So this will just come out to be a plus b sin theta, is equals to 2p plus 1 lambda by 2. That's it. It will be like this. এটাই আসবে, nothing more than that. No need to worry, nothing more than that. This one only. A plus b sin theta equals to 2p plus 1 lambda by 2. So that is what you will get, right? That's it, done. So maxima condition is done, minima condition is done, everything is over. So these are the conditions for maxima and minima in case of the interference pattern. And if you draw this interference pattern in between, so এখানে মাঝখানে ধরো এক জায়গায় আমি interference patternটা draw করে দিচ্ছি. So let me draw the interference pattern. This is the dashed line I draw, you understand why. So that the dashed line is drawn to just convince you that the peak heights, the maxima are of equal intensity. The maximas are of equal intensity, which you must take care. Oh no. So this cholbe রাখুন, it will go like this, just it will move in this particular way. Sorry. Yeah, That's fine. And here I drop up the intensity axis. This is my intensity axis and this one is my gamma axis, you may say. And what are the values of the maxima? Maxima gulo kothay hoy ami boleshilam. So what are the values of gamma maxima? So the maxima occur at gamma equals to m pi. So gamma equals to m pi mane amar ekhanete m pi mane 0 pi to pi, something like that. So this is 0. So this one should be pi and this one should be minus pi, and then this one should be twice pi, this one should be minus twice pi, and then why are the minimas of the interference? That is 2 pi plus 1 pi by 2. If I put p equals to 0, then the first one is at pi by 2. তাই না? p এর ভ্যালু যদি 0 বসাই প্রথমটা pi by 2 তে আসবে. So that's why I understand that my minima values are all these, this pi by 2, this 3 pi by 2, okay, and this one is some minus pi by 2, and this one is minus 3 pi by 2. That's how the things are going on. So এইভাবে পুরো সিচুয়েশনটা চলছে। তাহলে আমি তোমাকে কি দেখালাম? I have shown you the diffraction maxima, and diffraction এর এইগুলো একটু মার্ক করে দিও এখানে, হ্যাঁ, you please mark it from the last class that where actually these occurs. I am not doing it, okay? So আমি আর করছি না, তোমরা এগুলো একটু মার্ক করে দিও, হ্যাঁ, please mark this all, that where are these occurring, at what values of alpha you are getting all this. Please mark it from the single slit class. I hope that you have definitely done by this time. I believe in you that you people have done it. আমি আশা করি তোমরা করে ফেলেছো। আচ্ছা, এই গেল হচ্ছে তোমার পুরো স্টোরিটা, রাইট? সো হিয়ার ইউ হ্যাভ diffraction bands and you have the interference band. Now the question is that they cannot occur individually, independently. তারা তো independently হবে না, but they are related to each other. So what is the net effect? Because you see that I have taken the sin square alpha by alpha square individually, independently, and I have taken cos square gamma independently. দুটোকে আমি independently নিয়েছি, তাই তো? Sin square alpha by alpha square I have taken independently, and cos square gamma I have taken independently. Now let us take the mutual effect of these two, the simultaneous effect of these two. So what is the simultaneous effect of these two terms? So that means that I should overlap one over the another. So একটার উপর আরেকটা ওভারল্যাপ করতে হবে, and that overlapping you should again understand properly. So overlapping টা আবার বুঝতে হবে ভালো করে। তো overlapping এর জন্য এখন যেটা করছি, so width of diffraction band. So what is the width? Let us calculate the width of the bands. Width of diffraction band. Width of diffraction band, right? What is the width of diffraction band? So for the width of diffraction band, so you can just consider the two consecutive minima. You consider this minima, you consider this minima. So the difference between these two minimas will give you the bandwidth of the maxima. আরে দুটো পরপর মিনিমার মধ্যে যা ডিসটেন্স, ওটাই তো ম্যাক্সিমার একটা ব্যান্ড। So that is the width of a band. Got it? Again this minima to this minima, so that will again give you a band. So এটা থেকে আরেকটা ব্যান্ডের width তুমি পাবে, right? So let us calculate the width of any general diffraction band. Any general diffraction band, width of diffraction band, and this is definitely other than the central. This is generally other than central. Central ছাড়া অন্য কিন্তু। So width of diffraction band other than the central band. So you see that I write it over here. The condition of nth diffraction maxima, the condition for nth diffraction maxima, the condition for nth diffraction maxima is given by what? The condition for nth diffraction maxima is what? Nth diffraction maxima. What is the condition? The condition for nth diffraction maxima, what is it? Nth diffraction maxima, you know it. A sin theta is equals to n lambda, right? Or I may write here theta n is nearly equals to n lambda by a. For simplicity I take this sin theta to be small. Theta is small. For simplicity I take this sin theta to be small, okay? So I take this sin theta to be small. Sin theta কে আমরা small নিলাম। So that is the nth diffraction maxima. Sorry, this is not maxima, nth diffraction minima. Sorry, extremely sorry, nth diffraction minima. So the condition, the nth diffraction minima is given by this one. And for n plus 1th minima, for n plus 1th diffraction minima, I take two consecutive minima. দুটো consecutive minima আমরা নিচ্ছি এখানে। So this one should be again n plus 1 multiplied to lambda by a. So one is n lambda by a, another is n plus 1 lambda by a, okay? Theta n plus 1 is n plus 1 lambda by a. The nth diffraction minima and n plus 1th. So now if I take the difference of these two, so then I will get the angular separation, not the separation but the angular separation, angular separation টা। হ্যাঁ সোজা জিনিস রে ভাই, বোঝো ভালো করে। হ্যাঁ এইটা যাচ্ছে, এইটা আর এইটা, এইটা আর এইটা। সো আমি এইটা আর এটা বের করেছি। I have found this to be theta n and this to be some theta n plus 1. So if I just subtract these two, এই দুটোকে যদি subtract করি তাহলে আমি সেপারেশন পাবো, বাট এটা অ্যাঙ্গুলার সেপারেশন, দিস ইজ দ্য অ্যাঙ্গুলার সেপারেশন। ওকে, সো অ্যাঙ্গুলার সেপারেশনটাই বের করি, যা আছে তাই। সো অ্যাঙ্গুলার সেপারেশন I will be getting over here. So therefore angular width, what will be the angular width then? Angular width of nth diffraction, angular width of nth diffraction maxima, angular width of nth diffraction maxima, let me represent it by omega. So angular width of nth diffraction maxima other than the central I have said, so that should be theta n plus 1 minus theta n, and that gives me how much? n আর n কাটাকুটি cancellation, it is lambda by a. So I have omega is equals to lambda by a, right? So that is the width. So এটা মোটামুটি তোমার একটা width আসবে। So this is the width of the diffraction maxima, right? Understood? This is the width of the diffraction maxima. And for the central diffraction maxima, for central diffraction maxima, যদি সেন্ট্রালটা নিতে হয়, for central diffraction maxima we have to consider the width in between the two first minima, between the width between the two first minima, right? We have to consider the width in between the two first minima, which will be which you can simply write over here w naught is the central, তাহলে সেটা হয়ে যাবে twice lambda by a। তো সেটা কিন্তু 2 times of lambda by a আসবে। জাস্ট একটুখানি দেখিয়ে দিচ্ছি, I will show you in the diagram, you will automatically understand, তুমি নিজেই বুঝে যাবে। এই দেখো থিটা n এর ভ্যালু তো এটা এসছে, যদি এটা nth না হয়, যদি প্রথমটা হয়, প্রথমটা কেন? বিকজ দিস ইজ দ্য ডিফ্রাকশন প্যাটার্ন, ইউ নো, I will explain everything with respect to diagram. So এটা তো আচ্ছা, সেন্ট্রালের এইটা কোন মিনিমা? দিস ইজ হোয়াট মিনিমা? দিস ইজ n equals to 1 মিনিমা। দিস ইজ হোয়াট মিনিমা? দিস ইজ অলসো n equals to -1 মিনিমা। তাহলে এইদিকে একটা মিনিমা, এইদিকে একটা মিনিমা। দিস ইজ n equals to 2 মিনিমা, দিস ইজ n equals to 3 মিনিমা। If you have to calculate the width of this band, or if you have to calculate the width of this band, you just take the difference between 2 and 1 or 3 and 2, which I have done, n plus 1 and n. But if it is the central, when you have to take the width of this central, so then you have to consider once n equals to 1 and another you have to consider n equals to -1. So that means that this theta of 1 will give you some এখানে দেখিয়ে দিচ্ছি, দেখো। সো ওমেগা জিরো আমি ডাইরেক্ট বের করছি না, চলো আমি ডাইরেক্ট বের করব না, I will not find directly, I will write it to be, এটা যদি থিটা n plus 1 আর থিটা n হয়, এখানে কি বললাম? ইন বিটুইন টু ফার্স্ট মিনিমা। সো ওয়ান ফার্স্ট মিনিমা করসপন্ডস টু, একটা ফার্স্ট মিনিমা আসে কার জন্য? one of the first minima is for theta 1 and another first minima is for theta -1, right? The values of n. So এখান থেকে তুমি কি পাবে? So lambda by a and minus lambda by a, দেখে নে রে ভালো করে। If you put 1 it is lambda by a, if you put -1 it is minus lambda by a, and if you just take the subtraction, so that will yield how much? Twice lambda by a। তাহলে এখান থেকে চলে আসলো twice lambda by a, and you see that the central diffraction band is of different width than the other, which I was also speaking about in my classes of diffraction. ডিফ্রাকশনের ক্লাসে আমরা বলেছিলাম যে all the bandwidths, all the fringe widths are not same, এখানে fringe width কিন্তু সেম হয় না বলা হয়েছিল। তো সেটাই এখানে তুমি রিফ্লেকশন দেখতে পাচ্ছ, you can find the reflection, a manifestation of that the widths of the general diffraction maximas are lambda by a, but the central one is double of that. So এটা width হয়ে গেল। width of what? width of diffraction band. Now I will find the width of interference band. So let us now find the width of interference band. Width of interference band. At the end of the class the things will be very very interesting. দেখতে থাকো খালি। আচ্ছা, width of interference ব্যান্ড না বলে ম্যাক্সিমা বলা ভালো। আমি লাস্ট টাইম কি ম্যাক্সিমা বলেছি? তো লাস্ট টাইম ব্যান্ড বলো না, ডোন্ট সে ব্যান্ড, ম্যাক্সিমা। Other than central, maxima. Here also not band, maxima. আচ্ছা, ম্যাক্সিমা বের করতে গেলে মিনিমা ডিসাইডের কন্ডিশনটা লাগবে। ইউ নিড দ্য মিনিমাস। সো দ্য কন্ডিশন ফর ইন্টারফারেন্স মিনিমা, the condition for interference minima, nth interference minima, the condition for nth interference minima is, the condition for nth interference minima is how much? What is the condition? You know it very well. Interference minima বলে দিয়েছি একটু আগে কিন্তু, a plus b sin theta is equals to 2p plus 1 lambda by 2. P can take all values. Yeah, P can take all values. Interference minima, P can take all values. So condition for, এটা তো আবার nth হবে না, pth হবে, condition for pth interference minima. So from here also you can calculate this theta p, এটাকে আমি theta p বলছি. So this comes out to be some 2p plus 1 lambda divided by 2 times of d. A plus b কে আমি d লিখছি, হ্যাঁ, d equals to a plus b, double slit constant. And for p plus 1th interference, p plus 1th interference minima, so p plus 1th interference minima is theta p plus 1. So এখানে যদি p plus 1 করে দিই, so p plus 1 gives me 2p plus 3, 2p plus 3 lambda by twice d. So what is the width of the interference maxima? So therefore the width of interference, the width of interference maxima. What is the width? The distance between two successive minima is the width of the maxima. দুটো পরপর মিনিমার মধ্যে এই চলছে তো এরকম, like this it is going on like this. So this minima and this minima, I have found the position, এটা theta p and this is theta p plus 1. So if I take the separation, I get the angular width. এটা linear width নয় কিন্তু, this is not the linear width, the angular width I should mention. The angular width of the interference maxima is how much? Angular width টা কত আসবে? I call it omega dashed, that is theta p plus 1 minus theta p. So or omega dashed will turn out to be, so this will turn out to be 2p, 2p gets cancelled, 3 minus 1 is 2, 2 gets cancelled, lambda by d. So it was lambda by a for interference and lambda by d for diffraction. So okay, so that is what you understand, right? So the angular width of the interference maxima is given by this formula. Angular width is given by this formula. So from here whatever I understand is that, so conclusion, so what is the conclusion of this discussion? Why you are trying to find these widths? Width তো বের করলাম, বলতে পারবে আমরা কেন width বের করেছি? Why did I find the widths? So the widths are found because of this particular nature. Conclusion. Omega dashed is less than omega or omega 0. Omega dashed is less than omega or omega 0, right? So interference with অনেক কম, interference with is lesser because d is less than a. Since d is less than a, because d is a composition of a plus b, since d less than a, so therefore omega dashed is less than omega or omega 0. So what does it mean? So this means that within a particular diffraction band, so this implies that within a particular diffraction maxima, there can be a number of interference within a particular diffraction maxima, there can be a number of interference maxima. There can be a number of interference maxima, and it is given by কয়টা থাকবে একটা diffraction band এ কয়টা interference maxima থাকতে পারে, and it is given by for central diffraction band, this is given by n equals to, definitely it will be omega 0 by omega dashed, এটাই তো হবে। omega 0 হচ্ছে total width, this is the total width, and omega dash is the width of the individual interference, মানে এক একটা interference এর width. So by measuring this you can find that how many interferences are there, so how many interference band are there, মানে আমি তোমায় বলতে চাইছি যে একটা diffraction band এর width হচ্ছে 10 সেন্টিমিটার, কথার কথা ধরে নাও, just take it, imagine the width of a diffraction band is 10 centimeter and the width of a interference band is suppose 1 centimeter. So this means what? This means that within a particular diffraction band, একটা particular diffraction band এর মধ্যে there will be 10 interference maxima, এখানে 10টা interference maxima এখানে থাকবে, there will be 10 such interference maxima. That is what I want to say over here. তো সেটাই তোমাকে আমি বলতে চাইছি। Is it clear to you? Definitely I hope it is clear to you. So that is why the width I have found out. diffraction band এর width অনেক বেশি, সেজন্য একটা diffraction band এ অনেকগুলো interference maxima থাকবে। within a particular diffraction band there will be a number of interference maxima, and that number is basically given by omega 0 by omega dashed. So omega 0, I remember it is twice lambda by a, and this is lambda by d, so that comes out to be d by a, so that comes out to be d by a. So this is the number of 2d by a. So this is the number of interference maxima that are present within a diffraction band. So একটা diffraction band এ এতগুলো interference maxima থাকবে, this many number of interference maxima will be there for central diffraction band. আর for arbitrary অন্য যে কোনো, for arbitrary diffraction band this number will come out to be, this will be halved, এটা হয়ে যাবে omega 0 আর হবে না, it will be in general omega divided by omega dashed, and that gives you some d by a, এবং সেটা simply d by a আসবে, that will simply give you some d by a. So that are the issues which I wanted to discuss with you. So এই ধরনের ঘটনা কিছু তোমাদের সাথে আলোচনা করতে চাইছিলাম এবং সেটা করতে পারলাম, and I have been successful in doing so, right? So these are the issues that needed to be addressed and which we have been able to do so, and I hope that you have definitely understood them. I will draw the final IDF later on. So resultant intensity distribution I will draw after another particular discussion, I will draw it. So আরেকটা particular discussion হয়ে যাওয়ার পরে আমরা এই গোটা জিনিসটা আমরা draw করে নেব। Okay, just so the next and the last idea is the concept of missing orders, so which I would like to discuss with you. Missing orders. So what is the concept of missing orders in case of, double slit? Missing order ব্যাপারটা কি? Missing orders. What is the concept of missing orders? A few of the orders are missed. So what do you understand by that? A few of the interference maximas are missed in the diffraction pattern. So what is that? So you try to understand it. Let us write the condition for the interference maxima and the diffraction minima over here. So the reason behind this, you know, that we try to find the number of interference fringes within the central diffraction band or in other diffraction band, and from there we will have some concepts of the missing order. So let us try to understand about this concept of missing order. So I write the two condition once again. The condition for interference, maxima. The condition for interference maxima. So what is the condition for interference maxima? So I will be writing it out over here. And the condition, let me write the two issues. And the condition for diffraction minima diffraction minima, and that is, so let us have a look over here. So the condition for interference maxima is given by, as you know, it is a plus b. So you know that it is a plus b sine of theta, that comes out to be some m lambda, where there is no restriction on the value of m just belongs to I. Then I will be going for the condition for diffraction minima. The condition for diffraction minima, you know it to be a sine theta is equals to n lambda. So this is from the, so n belongs to I except n, but n not equals to 0. This is, you know, from the single slit classes and also from today's class. Right, so these are the two conditions. Now you see that if for some particular theta, যদি কোনো একটা particular theta জন্য এই দুটো condition একসাথে satisfy হয়, if for any particular theta these two conditions are simultaneously satisfied, then what do you expect? So then what do you expect? That is one of the important issues. Let me write it, and by that time you think what will happen. If for a particular theta the above two conditions are simultaneously satisfied, comma, then the corresponding interference maxima, will be absent or missing from the resultant IDF. Try to understand. বোঝো ভালো করে কেন এটা হচ্ছে. Try to understand that why this is actually happening in this particular case. Why this is happening in this particular case. You see that the two conditions that I have written over here, the interference maxima and the diffraction, the interference maxima and the diffraction minima, these are the independent conditions. So when I have got this condition, I did not use this at all. And when I have obtained this condition for the diffraction minima, you see that this is the condition I have obtained in the single slit class only, when there was no question about the diffraction interference of this type. So এই যে রিলেশনটা, এটা তো আমি কোন দিন পেয়েছিলাম, সিঙ্গেল স্লিটের ক্লাসে পেয়েছিলাম. সো তখন তো এটার কোনো অস্তিত্বই ছিল না. সো দেয়ার ওয়াজ নো সাচ রিলেশন অফ a plus b sin theta equals to m lambda, right? So these are the two independent conditions that you used to have when you studied the sin square alpha by alpha square term and the cos square gamma term independently. So দুটো টার্ম আমরা ওখানে independently আমরা স্টাডি করেছিলাম. So we are studying the terms independently over there. Now the idea is that if there is a simultaneous effect of both, so then actually what happens? So simultaneous effect, okay, so you have come to know that within the central diffraction band there are some interference and so on and everything are going on over here. But if the two thetas are simultaneously satisfied, দুটো theta যদি simultaneously satisfy করে যায়, তাহলে রিয়েলিটিতে কি পাবে? First of all, you try to understand that these are mathematical relationships. So when you have deduced the first one, you don't have any idea of the second. When you deduce the second one, you don't have any idea of the first one. So they are independent mathematical equations. But what actually happens in the real picture? রিয়েলিটিতে কি হয়, বাস্তবে কি দেখা যেতে পারে? In the reality, suppose these two conditions are simultaneously satisfied. So দুটো simultaneously satisfied মানে হচ্ছে dividing the above two. এই দুটোকে তুমি ভাগ করছো. কেন ভাগ করতে পারছো? বিকজ বোথ অফ দেম আর হ্যাভিং দ্য সেম ভ্যালু অফ থিটা. ধরো থিটা ইকুয়াল টু 30 ডিগ্রি, দেয়ার ইজ দ্য ডিফ্রাকশন মিনিমাম. থিটা ইকুয়াল টু 30 ডিগ্রিতে ডিফ্রাকশনের মিনিমাম আছে, রাইট? এবার ওখানে যদি ম্যাক্সিমা যদি তৈরিও হয়, ইফ আ ম্যাক্সিমা ইজ প্রেডিক্টেড ওভার দেয়ার ইন্টারফারেন্স, দ্যাট ম্যাক্সিমা ক্যানট ব্লো আপ. সেই ম্যাক্সিমাটা ওখানে তৈরি হবে না. That maxima cannot blow up. Try to understand. এইটা হচ্ছে diffraction band. This is the diffraction band that you have, diffraction band. And how are the interference bands? I have already drawn the diagram something like this. এগুলো interference band গুলো, right? This is the interference band. So এটা interference band গুলো তুমি পাচ্ছ. These are the interference band. Now suppose that there is a maxima at this point. এই পয়েন্টে ধরো একটা maxima ছিল at this particular point. But that maxima cannot blow up. সেই ম্যাক্সিমাটা এখানেতে তৈরি হবে না. That maxima cannot be blown up over here because there is no light. You have to understand that what is the reason of this interference. The reason of the interference is the interference between the lights diffracted from the two slits. তোমার কাছে দুটো স্লিট ছিল. You used to have two slits over here. you used to have, sorry, so you used to have two slits over here. তোমার কাছে দুটো slit ছিল, right? You are having two slits. So from here you have some diffraction, from here you have some diffraction, and these two light interfere among themselves, right? And if there is already a diffraction minima, that is there is no light from diffraction, okay, there is already a diffraction minima, that means that there is no light from diffraction, so there will be no question of interference. তাহলে তো সেখানে ইন্টারফারেন্স হওয়ার কোনো প্রশ্নই আসে না, there will be no interference. So then you may ask me that sir, then what is this? So this is when you have treated interference independently. এইটা তোমায় বুঝতে হবে, এইটা হচ্ছে শুধুমাত্র cos square gamma টার্মটার এফেক্ট. This is the effect of only the cos square gamma term, and this is the effect of the sin square alpha by alpha square term independently, right? That is what you need to understand over here. But when they togetherly play and come into the picture, so then what happens? If there is a diffraction minima, মানে diffraction থেকে কোনো লাইট আসছে না, the diffraction intensity is 0, and now if the two zero intensities interfere among themselves, যদি দুটো zero intensity নিজেদের মধ্যে interfere করে, if two zero intensities interfere among themselves, so then you will get zero light over there only, তাহলে তো তুমি জিরোই পাবে. So already mathematically there is a interference, but in the real picture, in the physical picture, there will be no interference, because you need to take the combination of the two terms simultaneously. And that is what is also reflected in this particular diagram. You look at these blue maximas. This blue is for interference. এই ব্লুটা আমরা ড্র করেছি ইন্টারফিয়ারেন্সের জন্য. The blue is for interference. তাই তো, ব্লুটা তো ইন্টারফারেন্সের জন্য. You used to know that the interference maxima are of same height. Interference maximas are of same intensity. But here you see this blue is the lowest, then it increases, and then again it starts to decrease on this side. So interference maximas are of equal intensity, but here you see it is of varying intensity, right? So again comes a question. So the answer is this diagram which I have drawn over here. So rightly this one, this diagram, this is for independent interference. That is, you have two source, তোমার কাছে দুটো source আছে, তাদের মধ্যে যে ইন্টারফারেন্সটা হচ্ছে. But the interference that I am discussing in today's class, this is the interference not from two source. This is the interference of the diffracted light. Interference of the diffracted light. That means diffraction has a role to play over here. এখানে diffraction এর একটা রোল আছে এখানেতে. cos square gamma একা এখানেতে প্লে করবে না. cos square gamma will not play the game independently. cos square gamma মাঠে একা খেলবে না. cos square gamma খেলবে, ওকে যেভাবে sin square alpha by alpha square কন্ট্রোল করবে. cos square gamma will just obey the orders of sin square alpha by alpha square. So sin square alpha by alpha square is the master and cos square gamma is the slave. Sin square alpha by alpha square হচ্ছে master মানে মালিক, আর cos square gamma হচ্ছে চাকর. cos square gamma is the slave over here. Okay, so that is what is going on. So cos square gamma has to follow the orders of sin square alpha by alpha square. Sin square alpha by alpha square যদি বলে যে আমি এখন মিনিমা হব, I will be minima, তখন cos square gamma যদি বলে, if cos square gamma says no, I will be maxima, that will be just rejected, because cos square gamma is the slave, ও হচ্ছে চাকর. cos square gamma has to follow the orders of sin square alpha by alpha square, because diffraction, and then it is the interference of the diffracted light. And that is why even if at this particular point, এই পয়েন্টে যদি ম্যাক্সিমা থাকেও ইন্টারফারেন্সে, there is a maxima that cannot blow up, সেটা দেখাতে পারবে না. And also the interference have uniform intensity, all the bands have uniform intensity, that can also not take place, and the intensities of the interference will also vary. Interference and intensity will vary করবে, because according to the orders of cos square gamma. I hope things has been understood. So now come to the missing order. So missing order মানে interference এর maxima mathematically, but there is a diffraction minima. So that means that the interference maxima will not turn up. So interference maxima টা আমরা দেখতে পাবো না, because the interference maxima is mathematical, but on reality there is a diffraction minimum, and the interference of two minima lights will definitely give you minima and not a maxima. So mathematically fine, but physically you will not get. So the order which you don't get, তাহলে যে অর্ডারটা আমি পেলাম না, the order which I don't get, that one is called the missing order. That one is called the missing order. So if I divide these two, a plus b by a, sin theta gets cancelled, and this side I have m by n. So from here I get the missing order, that is m is equals to n times of 1 plus b by a. So that is the missing order. So এটা হচ্ছে missing order. So you may write it in this way or you may write it in this way. M is equals to n of d by a. এটাও লেখা যেতে পারে. So you may follow either of these two. So let me highlight both of these two equations. So these two equations gives you the missing order in the diffraction pattern of a single slit. So এইটা তুমি missing orderটা পাবে. You will get the missing order in this particular way. I hope that the things have been understood by you. So তুমি কিন্তু জিনিসটা বুঝতে পেরেছো, right? So this order will be missing. Let me show you an example to clarify the things, and then I will draw a final diagram that will help you to understand the issues in a better order. So this one is the missing order. If the value comes out to be 2, if the value comes out to be 2, so then the second order will be missing. Now the missing orders are not always there. So বুঝতেই পারছো missing order তখনই থাকবে when d will be a multiple of a. When d will be a multiple of a, right? Integral multiple of a. So missing order হচ্ছে, so example, ধরে নাও b আর a যদি ইকুয়াল হয়, example, so example number 1, b is equals to a. So if b is equals to a, then m will turn out to be, b আর a যদি ইকুয়াল হয় তাহলে এখান থেকে দেখে নাও, if b and a are equal, so this turns out to be m equals to twice a. So what are the missing orders? So therefore missing orders, I write mo, okay? So missing orders is equals to, I don't write this way, আরো ভালো করে লিখি, that is m equals to 2, 4, 6, 8, dot dot dot, interference maxima will be missing. These interference maxima will be missing. Although they are interference maxima, but still they will be missed out, will be missing. কিচ্ছু করার নেই, nothing to do. Similarly, if I go for another example, suppose b equals to 2 times of a, so then you will have m equals to thrice of n. So that means that is m equals to you have n equals to 1 যদি use করি, so 3rd, 6th, 9th, dot dot, interference maximas will be missing. That is the idea, right? So now I will be showing you an example. So IDF, intensity distribution function এর প্যাটার্ন একটা দেখাবো আমি তোমাকে in presence of missing order, IDF pattern, and this is what I will be drawing for b equals to 2a. Now you see that if b equals to some 1.5a, ধরো b equals to 1.5, so b equals to যদি 1.5 হয়, if this is 1.5, so then m equals to 2.5, so তখন m চলে আসবে কিন্তু 2.5, right? আবার 2.5 আবার একটা ভালো নাম্বার হয়ে যাচ্ছে, ধরো you get something called 2.66 n, right? এরকম ভাবো, হ্যাঁ, তুমি ভাবো যে m এর ভ্যালুটা আসলো 2.66 টাইমস অফ n, রাইট? তাহলে তুমি দেখো তুমি কিন্তু মিসিং অর্ডার পাবে না। ইফ ইউ পুট n equals to 1, it is 2.66. 2.66 is not an order. Order গুলো কি? Only integer numbers are the order. You put n equal to 2, you get some 5 point something. So you get 3, you get some 7 point something, right? So something থাকলে these are not orders. Orders are 1, 2, 5, 7, 9, these are the orders. So under that circumstances there will be no missing order. তাহলে সেখানে কিন্তু কোনো মিসিং অর্ডার থাকবে না। So under that circumstances you will not have any missing orders, okay? So missing orders only be there when b is an integral multiple of a. So b আর a যখন একজন আরেকজনের মাল্টিপল হবে তখনই এটা হবে, otherwise not. So that is what I am trying to speak out over here. Now if there was only a diffraction, just like the single slit pattern, single slit pattern এর মতন যদি শুধু এখানে যদি diffraction থাকতো তাহলে কি হতো? If there is only diffraction, so I would get something like this. So তাহলে আমি এরকম কিছু একটা আমরা পেতাম এখানে, I would have obtained something like this. Please follow your textbooks as I suggest always for a proper diagrammatic approach. You know that a central diffraction band is always of double width than the others. So I show you 3 orders over here. 3টে order more or less দেখানোর চেষ্টা করলাম. So this is the for the single slit. If there was a single slit, you would have obtained a pattern like this. But what is the interplay of both the terms together? So this is only which term? Sin square alpha by alpha square. এটা কিন্তু শুধু sin square alpha by alpha square টার্মটা। আর cos square gamma টার্ম কোনটা? দেখো দুটো আলাদা আলাদা করে আমরা কিন্তু আগের ক্লাসে ড্র করেছি। I have drawn the two terms আগের ক্লাসে না এই ক্লাসে, সরি, I have drawn the two terms individual. You see that this is the diffraction term and this is the interference term. And now if I take this into this, এইটাকে যদি আমি এখন নিয়ে চলে যাই, if I take this over here, so then how will the resultant look like? So then how will the resultant look like? And you have to remember that this one is the master. So the master will control everything. Master will control everything over here. So this is the master. And the slave has to behave accordingly. So the magenta colors will be superimposed over here, but red will be the deciding factor. So red হচ্ছে envelope. Red is the envelope who will control everything. Because it is the interference of the diffracted light, not individual interference. So that is why the plot over here will be something like this. Try to understand, and then I will show you the missing orders also. The intensities may not appear properly over here, so because it's difficult to draw and I cannot take care of everything while drawing manually. So manually draw করার সময় সবকিছু take care করা সম্ভব না. It's always better to follow your textbook or to use some software. So you may use the softwares. So if you know the use of plotting software যদি কেউ use করতে পারো, if somebody can use the plotting software, so then you are encouraged to do so, because plotting softwares will help you to get the idea in a better manner. মানে ওই দুটো টার্মকে একসাথে তোমাকে দিতে হবে. You have to put those two terms simultaneously and the software will give you a correct plot. You see that the two sides are becoming asymmetry for me. দুটো সাইড থেকে আমি সিমেট্রি মেনটেন করতে পারছি না. I am unable to maintain the symmetry on both sides. So I cannot help it out more. Try to understand. মোটামুটি বুঝে নিও. Try to understand. And best is you follow your books, you will have it. Even you can find different resources online. You may also take help of those. So if you want to learn the things, there are many resources available nowadays. যদি শিখতে চাও, শেখার অনেক রাস্তা আছে. তো সেগুলো avail করে, you avail those, you understand the things. It is the central one. So I have tried to do in more or less in some way. So মোটামুটি আমি চেষ্টা করেছি. I have tried to do it. So you see that this is the resultant pattern. Now here you should take care of a few issues. So দু একটা জিনিস একটু এখানে take care করতে হবে. যেরকম হচ্ছে which orders are there and which orders are missing. So which orders are present? So you see that this is the 0th order interference maxima. Interference maxima actually starts from the 0th order. Just have a look. What was the condition for interference maxima? একটু দেখে নাও interference maxima condition গুলো. So width of interference maxima, no, not this one. Condition of interference maxima. A condition of interference maxima is a plus b sin theta equals to m lambda, and m belongs to I. So m can take values starting from 0. So m can start taking values from 0, right? So 0th order is definitely present over here. So 0th order থাকতেই পারে. So 0th order is definitely present over here. So this is my 0th order maxima, right? This is my first order maxima. Eta first order interference maxima. This is the second order interference maxima, and here was the third order interference maxima. You see that এত বড় গ্যাপ থাকতে পারে না. This much cannot be the gap in a maxima, because interference maximas are equally spaced. এটা জানো তো, interference maximas are equally spaced. You know beta equals to lambda capital D by small d in case of that double slits. So you see that over here the interference maximas are equally spaced, but here so the gapping is large. এখান থেকে এখানে দেখো a very small gap, এখান থেকে এখানে a very small gap. These are equivalent, same type of gap, but here to here you see that there is a huge gap. So this actually shows that there was a inbuilt, there was a in between maxima. এখানে একটা আরেকটা maxima ছিল. There was a maxima over here also, but that maxima could not grow up. কিন্তু সেই maximaটা আমরা দেখতে পাচ্ছি না. কেন? We cannot see that maxima because of the presence of the diffraction minima over here, right? So this is what is the missing order that I was speaking of. So এই মিসিংটার কথাই আমরা এখানে বলছিলাম. তাহলে 3 নাম্বারটা দেখো মিসিং হচ্ছে, এবং চোখের সামনে পরিষ্কার, কারণ এতটা গ্যাপ তো থাকবে না. This should not be the gap over here. So in between there is something. So similarly, this is my 4, this is my 5, and my 6 is again missing. Six is again missing. I have 7, I have 8, 9 is again missing. This side also, I have 4, I have 5, 6 is missing. I have 7, I have 8, and 9 is again missing. Yo, that's fine. So the missing ones, I just mark them with a different color. I just circle them. So 3 is missing, 6 is missing. Actually, that's not a maximal position, but these maxima are found where? These maxima are found in the position of diffraction minimas. So that is why those maxima will not come into the picture. Because interference, I used to say slave. Interference ke ami chakor bolchi, slave. It has to follow the orders of diffraction. And this is the case for B equals to 2D. So this is how the double slit pattern looks like. So when you look for experiment, you will not see this blue dotted lines. এই ব্লুটা দেখতে পাবে না কিন্তু ব্লুটা হচ্ছে কন্ট্রোল করছে কাকে? whom. Blue is controlling whom? Blue is controlling the red one. And the picture that you will find finally is this one. তুমি finally যে পিকচারটা পাবে সেটা হচ্ছে এইটা something like this. So this is the double slit pattern that you will obtain over here. So this is the combined effect of combo. It is the combo of diffraction plus interference. এই দুটোর combination effect হচ্ছে এটা যেটা দেখা যাচ্ছে, right? So you find a combination effect over here. So that is combination. Why? Because if it was only diffraction, যদি শুধু diffraction হতো তাহলে তুমি this band, then this band, then the central band and the two others band, just like the single C. খালি এইটুকু band দেখতে পেতে. But as the interference is there, so you will find some more bands. So inside this there are bands. এটার ভিতরে আবার band আছে. Inside this there are actually many bands in the central, and there is band. So the number of bands has increased in the double slit. Number of bands এখানে বেড়ে গেছে, and the reason is interference, not diffraction. Band বাড়ার কারণ কিন্তু diffraction নয়. It is interference over here. But this is again not a true interference. This is not true interference, because true interference, all the maxima should be of equal illumination, of equal height. প্রত্যেকটা maxima equal height এর হওয়া ছিল, but all the maximas are not of equal height. So you can say that this is not a pure interference, and this is also not a pure diffraction. This is a combo of interference and diffraction, right? And finally, I have a calculation that how can you find that how many number of fringes are there, how many interference maxima are there inside the central diffraction band. So how many maximas are there, interference maximas are there within the central diffraction band? So that is what we will be trying to calculate next. So I just put up a heading, number of interference maxima. You will say that, sir, this is what you have done previously just before 15 minutes. So again, what are you trying to do? No, in the last case, there was no missing order. It was a general treatment. But now I am considering missing order. Number of interference maxima within central diffraction, within central diffraction band, in presence of missing orders. In presence of missing orders. So missing order থাকলে তখন এটা কি করে বের করবে? The idea is very simple, not at all difficult. একদমই difficult কিছু নেই, just দেখে নাও. So condition for diffraction minima. So first of all I will write that what are the missing order? So missing order কোনটা? The missing orders for diffraction, the missing order for interference maxima is given by, the missing orders for interference maxima is given by m equals to, you have learned the formula, 1 plus b by a or d by a times of n, right? এখানে n টা কি? n is the diffraction minimum. এনটা হচ্ছে ডিফ্রাকশন মিনিমাম। এবার যদি আমাকে সেন্ট্রাল ডিফ্রাকশন ব্যান্ডটা ধরতে হয়, সো ফর সেন্ট্রাল ডিফ্রাকশন ব্যান্ড, on either side we have the first minimum, right? That means that is n is equals to 1. Is the idea clear? Central diffraction band মানে তার দুই দিকে কোন মিনিমাটা থাকবে? Central diffraction band তাহলে এটা কি? This is the first minima, this is the first minima on the other side. So basically the value of n is 1. For the next minima it is n equals to 2, because you know that the minima cannot be n equal to 0. The minima actually starts from n equals to 1. So n equals to 1 gives you the first minima corresponding to the central diffraction band. তাহলে central diffraction band পেতে গেলে আমাকে n equals to 1 এখানে ইউজ করতে হবে। So therefore what is the missing order? So m equals to d by a. So এই অর্ডারটা মিস হবে। So this order will be missed, d by a. If the value of d by a comes out to be 3 as in the last example, so then the third order will be missing, right? d by a এর ভ্যালু যদি 3 আসে তাহলে থার্ড অর্ডারটা মিসিং হবে, বোঝা যাচ্ছে? তাহলে থার্ড অর্ডারটা মিসিং হবে। So this one is the missing order। তাহলে লেখো therefore the missing order of interference maxima is equals to d by a. So d by a এই অর্ডারটা মিসিং হবে, রাইট? তাহলে থাকবে কোনগুলো? if the third order is missed, so then up to which order is present? আনসার করো। থার্ড অর্ডার যদি মিস হয় তাহলে কোন অর্ডার অবধি আছে? which order is present? definitely up to 2, second order is present। তাহলে এখানে লেখো so the number of interference maxima, so the number of interference maxima present within the central diffraction maxima, number of interference maxima present within the central diffraction maxima on one side, you know that there are two sides, একদিকে কটা হবে? So on one side, which, how many? That must be d by a minus 1. আরে সোজা জিনিস, থার্ড অর্ডারটা মিস হয়েছে, থার্ড অর্ডার is missed, then which order up to is present? Up to second order is present, so that is 3 minus 1, that is d by a minus 1. এটা একদিকে up to 2 it is present. Considering both sides, what will happen? So considering both sides, the number of interference maxima, within the central diffraction band, বলো কটা হবে? both sides ধরলে কি হবে? এটা 2 দিয়ে মাল্টিপ্লাই হবে। if I consider both sides I have to multiply it by 2, so it is 2 d by a minus 1. So considering both sides, the number of interference maxima, considering both sides, the number of interference maxima within the central diffraction band, considering both sides, that should be 2 times of d by a minus 1. Purely understand? তাহলে এতগুলো থাকবে। But you have missed somebody. তুমি আরেকজনকে ভুলে গেছো, you have forgot one. But we have to consider also the central interference maximum, right? তার মানে কোনটা? that is the 0th order, তাহলে finally therefore thus the total number of interference maxima within the central diffraction band is equals to, considering one side it was d by a minus 1, considering both sides I have a 2 এখানে অবধি হলো, and একটা এক্সট্রা আছে, third order is missing, তার মানে up to second order is present. So 1 and 2 on the right side, 1 and 2 on the left side হলো। তাহলে কটা হলো? 4টে হলো, in total 4। আর 0টা কে ধরবে? who will consider the 0? So that is why 1 extra which takes care of the 0. So this gives you 2d by a minus 1. A very important question for the exam. show that the number of diffraction maxima, interference maxima within the central diffraction band is 2d by a minus 1. And if there is no missing order, so then you have already calculated it on the last class, it was 2d by a. So যদি কোনো মিসিং অর্ডার না থাকে তাহলে সেটা 2d by a হবে, যেটা লাস্ট ক্লাসে বের করেছো, which you have calculated on your last class, right? And now you can use it in our fact. এবার তুমি এটা আমাদের এখানে ইউজ করতে পারো, যে এক্সাম্পলটা আমরা নিয়েছিলাম, that b equals to 2a, b equals to 2a মানে d মানে কত, so d is a plus b, so d actually gives you how much, d actually gives you 3a, তার মানে d হচ্ছে সেখানে 3a, তাহলে আমাদের এক্সাম্পলে d is 3a, so if I use it over here, so if I use d equals to 3, এটা রাফ, হ্যাঁ, this d equals to 3a, so the number of fringes that will come out, so this comes out to be 5, 3 বসাচ্ছি এখানে, 2 3s are 6 minus 1 is 5, পাঁচটা থাকবে। সো উইদিন দ্য সেন্ট্রাল ডিফ্রাকশন ব্যান্ড দেয়ার উইল বি 5 ইন্টারফারেন্স ম্যাক্সিমা। এই দেখো কাউন্ট করে কত আসে, কাউন্ট ইট, দেখো কাউন্ট করো, 1 2 3 4 5, ফ্যান্টাস্টিক, রাইট? সো দিস ইজ হোয়াট আই অ্যাকচুয়ালি ইন্টেন্ডেড টু সে ইউ, বাট ইউ রিমেম্বার দ্য ফর্মুলা ইজ ফর দ্য সেন্ট্রাল ডিফ্রাকশন অনলি, not for the others. If you have to do for the others, so then you have to tackle it accordingly. বাকিগুলো করতে গেলে accordingly tackle করতে হবে কিন্তু, হ্যাঁ, এটা শুধু সেন্ট্রালটার জন্য আমি করলাম, this is what I have done for the central only, fine? So this was all about that I needed to explain on the double slit pattern. So double slit pattern এ আমার এইটুকুই বলার ছিল, যেটা হয়ে গেছে, which I have been able to do so. Now your task is that what will happen if we change, increase or decrease this A and B, just like the single slit. This is your task to do so. Everything I have done, so তোমাদেরকে একটা ছোট কাজ দিলাম, জাস্ট এইটা তুমি করবে, you will do this, and this will definitely just increase or decrease the width or the intensities of the interference and diffraction maximum minimum. So এটা কিছুই করবে না, খালি যে ফ্রিঞ্জ গুলো তৈরি হয়েছিল, the bands that are produced, so it will increase or decrease the size and the illumination of such bands. So that is what you will do so, because otherwise there is less probability that you will go through the books. So this will at least forcefully you need to use the books. So that is why I can discuss this for the more 10 minutes, so 10 minutes dile eta discuss hoye jabe, but deliberately I will not do so, because that will help you to go through the books, and whenever you go through the books some other issues will come in front of you. boita khulle ta chot kore answer ta pabe na, you will not get the answer, you have to read it, and then you will get some information also, aro kichu information tumi pabe, that is definitely going to help you for your studies. So thanks to all of you for your kind attentions, and here I will be winding up for